Hello everyone, this is I Can't Code and it's in the name, I really can't code. And then on my channel, you'll see a lot of stupid experiments, like something like Qwen 2.5 VLM OCR. What the hell is that? It just performs OCR, but it's there and you can always play with it with the Dockerized setup if you have an NVIDIA GPU, whatever. Same with Qwen 3 2 billion OCR app. Same with Hunyuan 1 billion OCR app, right? Like you can do that. But that is actually not the point of the channel. Our goal here is to create a nice retrieval augmented generation system, and then whatever we need to achieve it. And we want to achieve it in the less amount of dollars as possible, right? We don't want to spend money on a freaking H100 because not a lot of people can afford H100 or H200, whatever's the going term for the best GPU in the market. Dude, we got a MI50. Okay, let me minimize this thing. Okay, we have an MI50. Okay, this thing is so beautiful. I don't even care. Dude, I'm not gonna be fine tuning like on a freaking, like I'm not training a 100 billion parameter model. I just, there you don't necessarily need to go crazy. You could just read this beautiful paper. I'm gonna, this is less is more augmented alignment. Go back to page number 6. Okay, these people, right? These people are so beautiful. I love these people. While preliminary experiments show that basically, if you have 2,000 samples for a 7 billion parameter model, you're good. But we have a 4 billion parameter model, this bad boy right here, that we're going to be fine tuning on this channel, okay? Not in this video, in this channel. We're going to actually generate about 5,000 samples for this bad boy on construction. And the goal is to make it construction fluent, meaning it needs to know what the heck to expect and what to say, right? Basically, it needs to know, it needs to understand, we need to train it, right? And then we need to use our retrieval augmented generation app so that, the 4 billion parameter model can, be useful. Now, OCR is one of the key things, and the beautiful thing about construction is that now a lot of the documents are computer generated, meaning like for example this is computer generated. You can extract the text very easily and efficiently. You don't need a vision language model to extract all this text. Is it good? Yes. Can you do it? Yes. But do you need to do it? No. You can use exaOCR, which I want to give a huge shout out to OCR my PDF team. I mean, did I give a shout out to those guys here? Oh Lord, they're gonna kill me. They're nice people. Let's just go to OCR my PDF, okay? Because those people, they deserve all the praise in the world. But OCR my PDF, this team has done great. It is based off of Tesseract OCR, but listen to me. Let me tell you something. This thing does magic, okay? And you can deploy Exa OCR to try it yourself. It uses OCR my PDF. It's not like I did something crazy with it. All I did is I wrapped it, and then so this way I could use it on my pipeline, right? So and I didn't pick that pipeline word from here. It's actually for exaPipeline. So the fast API application, that is what we need. So that's what we have set up here. This is exaOCR, okay, and it's deployed. The Streamlit, I'm too lazy to get rid of Streamlit, and I need to test it every now and then, so it's there. This is pulled right from the repo it's running, and as you can see, I was testing with it right now. So this is the purpose of exaOCR. And then so our pipeline, we just synthesized a data set, and dude, I recorded like a 27-minute video. I'm not gonna do this thing again. Okay, I'm tired. I need to rest. It's a Sunday, or no, it's a Saturday. I have something to do on Sunday. But anyways, this is an entire pipeline. We're gonna go over it. I'll show you the Streamlit. Don't worry about it. And it's sleeping right now. This is our VLLM instance running the MI50, and it is actually running the Qwen 3 4 billion parameter instruct model at FP8. I'm sorry, I take that back. It is actually the AWQ model. And then that is also on our repository. Our repositories right here. So if you have an MI50, you can just take this bad boy and just do Docker compose up and call it a day right there. In any event, the whole purpose of this video is to show you the exaPipeline, which I just did briefly. We're going to be improving this so that we can create data sets. Now, the issue that I ran into recently is to do with You want to pull exaPipeline Docker Compose up this thing, and then you want to also pull this and bring this up because this is a separate Streamlit app. I didn't want to like cram everything into one thing. This is separately maintained. This is separately maintained, and then if you understand the API enough, you can actually build your own, web UI, whatever. Like that's for another video to talk about. But did I push? I did not. Well, I just created it. So here is, our issue. Okay, we have the exaPipeline. It is generating data sets, and this is what the data set looks like. Is it good? Absolutely not. Is it synthetic data? Yes. So let's look at what that looks like. Come on, baby, where are you? Right. So we clicked. It automatically generates the data set for you. And then you need to also show where your whole thing is. So where is your, for example, if you go to exaPipeline, right? Then we go cat.env. I could have shown, actually, I'm an idiot. I could have shown you this in the VS Code as well. But you need to deploy exa OCR, and then you need to point out which port it is using and what IP address it has. If it's on the same system, then you need to say localhost or whatever, or you could still use the IP. But if it's on a server, like I have this deployed on my server, then you can just say, okay, all right, it's on this server on this port. Same with VLLM. Same with your Redis database. Where's that? And then so everything else is pretty standard. You just leave it like that. I pushed the .env file in it as well because it's not like I'm giving you the secrets to the freaking, whatever, military codes or whatever. It's exaPipeline, doesn't even work right. But the key issue that exaPipeline has at the moment is that the data set is garbage. Congratulations. Who could have thought this garbage could be generated in 24 hours? So I spent 24 hours creating this thing. It is able to create synthesized data set. Is it good? Absolutely. Actually, you know what? It is not that bad. I will lie if I said it's bad. It is not that bad. Okay. Oh my God. Actually, I'm paying more attention now. Holy shit. It's not that bad either. But I don't want it like that. I want it like this. I want to see what the question is and I want to see what the answer is. Okay? I wanted to understand everything. So now the thing is, we have that. We have the PDF LLM. What the heck? I'm just clicking stuff. Aren't I? But good Lord. This is the RAG app. We need to use the RAG app in coordination with exaOCR so that our pipeline can understand everything. But there's still a key issue. How does one differentiate between what needs to be synthesized and what not? So this right here can be synthesized. This cannot be, should not be synthesized. This is a request for information document. This is very legal. You cannot, okay, synthesize this thing. You need to make sense of the question. How do you make sense of the question? You need to look at the sheet S103, which is a drawing, right? It's a structural sheet. You need to look at it so that you can get this question straight. Is this question legitimate? Yes. Then after that, you need to make sense of the answer that the architect gives you, or in this case, the engineer, not the architect. The engineer gives you, okay? And then you do not synthesize these two bad boys. This has no confidential data in it. This has confidential data, so you synthesize it. So how do you pick up what to synthesize and what to not? So what we're doing now, and I was just doing this before this video started, is we are actually building a what's it called, a exaPipeline knowledge separator. And the knowledge separator, right, its purpose is going to be to recognize the documents, create a metadata to tell, or in the metadata, we want to store what data should be synthesized and what data shouldn't be synthesized. So how do you do that? Well, you leverage the large language model. Okay, and then you tell it that, okay, identify the transmittal and then only change the addresses, the date, the company names, and whatever else, right? I'm too tired to talk right now. But you basically do that. And then this knowledge separator, it acts like a preprocessor to the document. It then goes into the pipeline, which then, well, if we go this route, then we do not need to. We would just perform the OCR here, because we can also do that. We can perform the OCR and then have a better understanding of the document, and then we would essentially have a metadata to basically put into this pipeline, which would then go to the LLM again and then generate the data set, synthesized data set, and then in Streamlit it would just give you the data set to download, and then it would be far less idiotic than this. Actually, you know what? I won't lie. This is not idiotic. This is, I'm looking at it closely now. Like, God, this is really good. You have to understand what I'm telling you as a contractor. This is not making sense in the video. There's a lot of shit in it, but it's not bad. Like, it's picking up the names already, synthesizing it. But what I have an issue with is I can't live with this question or a prompt. Like, this is not the content. This needs to be in a question and answer format, so this way we can say, things like understand this document or what have you, or change this document, and then we need a proper thing. We don't need to synthesize the entire document. We need to train it. The idea is to train it, not to inject literal document into it. So this is going to be a fun little adventure. I look forward to sharing more with you guys. So take care. Bye bye.